All right, good morning. It's still the morning. So, basically the motivation for this talk and a quick synopsis. Most access controls suck. They're using really old protocols, clear text, and they're very widespread. We're seeing this in 80% of deployments. And taking a look at this, Mark, he does physical pen testing. He said, hey, it would be really cool to build a device that could let us play around with this protocol, maybe add some wireless. And so we went, okay, let's build something. So we built the thing, and we're going to tell you about it. We're going to go through a bit of a history of RFID and tell you sort of how these readers work, what technologies are used. Then we'll talk about the device we built, how you can use it for penetration testing, and also how you could prevent against the type of attacks that it can do. Quick introduction. My name is Eric Evanchik. I am an embedded systems architect at Faraday Future. We're a new car company that's building an electric vehicle from the ground up. I've never got to say this before to talk, but we're hiring, so I get to do that for once. If you want to work on cars, come find me and reach out. Mark?
All right, and I'm Mark Passaggio. I'm a managing principal consultant at Accuvant, Fishnet, Optiv, whatever you want to call us now. I work on the attack and pen team. We do network security and also, obviously, physical penetration testing. We're also hiring. Hit me up on Twitter or go over to the recruiting booth where we're giving away 200 of these this week. So I wanted to talk a little bit about the motivation behind building this. Eric filled you in a little bit briefly, but I'm going to go into it in more depth. So as you see on the left-hand side here, we have an HID prox reader in a big bank, and then a refinery. Now these aren't the only two places that you can find this technology. This is a shot with Eric in the side there at Pearson International Airport as we're flying to DEF CON. This is also an HID prox reader. It's also vulnerable. So banks, offices, manufacturing facilities, et cetera, worldwide, in my experience, I've done work in North America, done work in Europe and in Asia. The utilization across the continents is a bit different, but it's definitely everywhere. So no matter where I would go, customers would always be surprised when I cloned a badge, used our Tastic RFID thief to long range read a badge and then clone it. So I started thinking to myself, well, we really need to build something that gets the point, drives the point home and hopefully kills Wiegand once and for all. Nothing against the man. It was a great protocol, but it's past its time. So let's illustrate a bit how these systems work. We're going to be really basic here. This is an RFID reader. It sends out a signal. And right now, it's a little sad because it's got no card to read. So we're going to introduce a card. And the card, once introduced, is energized by the reader and sends bits back completely in the clear. And the reader's like, all right, I got data. And so it has to do something with this data. So this is what we're interested in. This is called the upstream, where it sends the data from the card reader to an upstream device, typically a door controller, which is what's pictured here. And that data is the bit stream that was on the card. It's called Wiegand. So this is what we're going to attack today. Wiegand is clear text, as Eric said. It has been around for decades, and it's literally everywhere. But we'll get into that a bit more later. So here's the whole system in one slide in case I went too fast for you there. Again, the bit we care about, Wiegand, is in red. But we're going to shift gears for a moment, and Eric's going to fill you in a bit about the history of readers. Now, it seems like we're picking on HID today, but that's just because of their prominence in the marketplace. It's not anything brand specific. They're just everywhere, and we see them all the time. Other manufacturers are also vulnerable to this attack.
So we'll start off with 20 years ago in our history lesson, and this is HID prox. It is a completely unencrypted system all over. So the card to the reader, there's no encryption there. The reader to the door controller, also no encryption. They're also all over the place. These are two of the more popular layouts. We have another one right here, which is without the pin pad. You'll see these in smaller configurations, bigger ones that look like this guy, just all sorts of different knockoffs. If you saw our picture from Pearson Airport, also you'll see different company names, but they look very similar. The truth is they just stick a sticker over the HID logo and sell it as a different brand. It's a popular thing to do. Some do have this two-factor authentication, and I should say that with two-factor authentication doesn't quite work as you might expect. When you push buttons on that pin pad, it sends bits back over the clear text Wiegand protocol in the clear to the door controller. So the attacks we're showing doesn't help you. We'll move forward about 10 years to HID I-class. Big note here is they introduced encryption between the card and the reader. The only problem is, well, they got broken. Back in 2010, a guy by the name of Milos Mariak, he discovered, hey, I can use some tricks here and get the firmware out. Once I get the firmware out, I can get this DES key that they're using to encrypt the cards. And oh, they're using the same key in every reader worldwide. So that's a slight problem when it's a symmetric key, as you might assume. The big thing with this is they still say that this is, these are words that we took from their website last week. They still say it's enhanced security, it's mutual authentication. And it's not untrue. But it's kind of like saying TLS 1.0 is all these things. It is, but you still don't want to use it. These are super prominent. And the real key with our talk, we're not talking too much about the card encryption, more about the back-end protocol. These still only support Wiegand and another format called clock and data, which is still clear text. It's just a different signaling protocol. It's pretty much the same thing, just different bits on different lines. Now we'll move into the future. This is a couple years ago. I-class SE came out. And this does support a new protocol called OSDP, Open Supervised Device Protocol. And that does offer an option called SCP, Secure Channel Protocol, and that is encrypted. That being said, it still does Wiegand. And if you install it and don't specify that you want OSDP and wire it for OSDP and buy new door controllers that support OSDP or modules that convert between the two, it's still going to do Wiegand. So you might think, hey, I'm buying a better reader, but it turns out, nah, it's the same old stuff, just with a different badge on it. On the card side, they are supporting a new type of card called I-class SE cards. And the whole theme of this, though, is that no one's looked into them too much, so your mileage may vary on security of this device. But this particular reader, it says in very small letters that you might not be able to read, multi-class. And you'll see these on I-class as well, multi-class. What that means is it can do multiple different old versions of the cards. So this reader, out of the box with the right configuration, will do prox, I-class, I-class SE, which means if you use a prox card on it, it will accept that as a valid credential, which sort of breaks the whole idea of using encrypted credentials in the first place. The main point being, yeah, this could be a more secure option, but you still have to set it up right and make sure it's been configured with those options enabled and with all the old stuff disabled. So the real question here is, does anyone use one of these to get into their office? Anyone? I'm guessing a few people. I see some people are willing to put up hands, maybe some aren't. But the truth is, I walk by 10 or 20 of these things every day on my way to work. They're just everywhere. And you'll find one wherever you go. So now Mark is going to talk a bit more about this protocol that we're exploiting and where it came from and how we can deal with it. Mark?
Thanks, Eric. So this is John R. Wiegand. About 30 years ago or so, he discovered this special type of wire that had magnetic properties. And this wire was then embedded into cards. And based on the presence of the wire or an absence of the wire in the card, when it was pulled through a reader, it created a bit stream of ones and zeros. So the protocol used to transmit that information on the back end became known as the Wiegand protocol. This guy's got a lot of stuff named after him. He's a physicist, and I think that he's passed on, but his protocol certainly lives on today. The constraints that are in current access control systems around bit length are as a result of the amount of wires that you could fit into a card. So we have this cycle of backwards compatibility with this protocol that dates back to the Apollo 11 era. And it's the reason that 8 bits of data is for a card code and 16 bits of data is for a facility code, typically in most of these cards. And into I-class as well. So going towards 20 years later. So we have a vicious cycle of backwards compatibility where people use something, so they implement it in RFID, and then it's in buildings, then it's in more demand, and 30 years later, here we are with the same protocol. Now I want to show you the protocol. Wiegand uses only 2 lines plus ground. Line 1 would be on the top of this slide. Data 0 on the top, data 1 on the bottom. Vertically, we have voltage. So it goes from 0 volts to 5 volts. The lines are normally just held high at 5 volts. The horizontal axis is time. So this is how we read the Wiegand protocol. This is 2 bits, a 0 and a 1. And on the falling edge, what's called the falling edge when we read it with a microcontroller, we count a 0. And on the falling edge, as time goes on, then we've received a 1 now in this data stream. So with a 26-bit card, when we put all that together, this is a logic analyzer screenshot from an entire card. We have data from the card. So what can we do with this data? Well, it turns out we can do quite a bit. So as you see here, we have the bit stream, and I've highlighted the first 8 bits. That's the facility code in your card. And the interesting thing is a lot of places order cards in bulk. So if you're a company with 30 employees, chances are your entire office has the same facility code. So that significantly reduces the difficulty to guess a card number. And then the next 16 bits that we're going to highlight here are the card code, 29,644. So in this particular facility, I'm betting that 29,643 and also 45 are valid cards. Say I'm an employee, I'm disgruntled, and I'm let go, I know that probably the next card also works to open the door. And you can take this data. This is all you need to create a clone or to replay data on the lines if you have a device like BLEKey attached to the lines. This is a funny one that we had to point out. We're taking a little sidetrack here, but this is a bit of a facepalm. This is a dual technology card. So it has an antenna for I-class, which is high frequency. It has an antenna for prox, which is low frequency, 2 separate chips. And on this card, the authentication data on the encrypted portion and the completely clear portion is identical. So if in the situation we showed you before, where you have a multi-class reader, but are using only, say encrypted credentials, but you have this multi-class card, you can read the unencrypted information. I can take it back because I-class is broken, store it onto one of those cards, and get into the building. Now, the bigger facepalm is that you see that yellow box? The data 270, that's the card code, and 05994, that's the facility code. You don't even need to read it. You just need to see it around someone's neck, and you can get in or replay the data with our BLEKey. So HID, I don't think they willingly do this, but we accessed this site today. And this is the latest I-class SE card that you can buy from them that is the highest security. It has an encrypted side, works with I-class SE. And also, again, they've released this dual technology card, so it has an unencrypted side. And it says right on their website, it communicates no traceable identifiers during card sessions to prevent card data from being divulged or cloned by unauthorized parties, which is totally misleading to the customer. Because yeah, sure, if you're only using the encrypted side, which has not been tested by security researchers, then yes, it may be protected. But if I can walk by you with a device like that and lift it off your belt, I can get into your facility. So the moral of the story here is that physical access to these readers, physical access to this information is winning. Now we want to give some people some props. This protocol weakness has been around for 20 years. In the design of Wiegand, they didn't implement security because it was not feasible at that time to put together a device like this. It was inaccessible. It was probably the realm of engineers to access this information. and put together something that would emulate a card or transmit on the Wiegand lines. But now, with the Arduino and whatnot, it's a lot more accessible. So we want to thank a guy named PageMac. He had some Arduino code just posted right on the internet. When I Googled, I found it. It's like, wow, this is really easy to read, this protocol. Another guy named Carl from Proxclone, he's got a site called Proxclone. He just experiments on iClass, and he's really open about it, and he puts all his information out there, writes white papers. He never presents at cons like this, but I sent him an email, and he gave me all the information I needed to turn an iClass reader into a cloner right on the wall. Pretty cool guy. And then, of course, we must give a nod to Zach Franken, who made a device that was quite like ours, called the Gecko, back in 2008. Now, obviously, you're all sitting here today. We're talking about this today. We think that the Gecko wasn't released, as far as we know, and probably didn't have the impact that it should have, because everyone's still using this. So here we are again, and we made a device that we think's a little bit easier to use and now has wireless. So we made
the BLEKey. So let's talk about the hardware that we're releasing today as open source hardware. And basically the whole reason why you're here is this little device. You probably can't even see it in my hand if you're at the back. It's pretty small. It's 18 by 30 millimeters, or 0.7 by 1.2 inches. And there it is next to a Canadian quarter, which is the same size as an American quarter, but worth 30% less. We utilize this module here. It's a Bluetooth low energy module from a company called Raytac. And it's great because they do all the RF black magic for us. No antenna matching, no VNAs, no, if you've ever done RF, it's a lot of work. So we just take that module, put it down. It has a Nordic NRF 51822 chip on it. This is super popular in connected devices like Fitbit type things. It's a processor that has not only a Cortex M0 ARM chip or ARM core, but also a 2.4 gigahertz radio, and they provide a software stack that turns that into a Bluetooth low energy device. So it's kind of everything you need in one chip, and it's FCC certified, so we don't have to do that. Now, the rest of the board, it's pretty simple. It's a few passive components and some transistors to drive the lines, connectors, there's a battery holder on the back. Really, the other kind of innovative part of the design is the connector. We used an insulation displacement connector. A lot of you are probably familiar with one type of this connector, which would be an RJ45 connector. When you crimp that down, you know how those little teeth go up and they pierce through the insulation, but they don't actually cut the wire at all? That's what this does. So you stick the wire in, you punch it down, the reader will still work normally. You've just made an electrical connection without cutting or splicing. Makes it fast to install and also doesn't break the existing system. And it runs on a CR1632 coin cell, which is a tiny little coin cell battery you stick in the back. So this is our high-tech development setup in our lab. You need really sophisticated equipment to build one of these. Not really. This is Mark's desk, and we soldered up the first ones literally here with a hot air rework station and patience. And this is the entire schematic. There's nothing else. It fits on a slide, so you know it's simple. Again, this will be released as open source hardware. We're going to have it up on GitHub. So if you want to take a deeper look into it, you can do that. It's worth noting, Mark had no experience with the program we used, which is KiCad or KiCad. He had never used it before. He did the first version of the schematic, and then I came in and did an extra vision, but it's pretty simple stuff. You don't need to be some electronics wizard to build a device that will break 80% of access control readers out there. We went through some design iterations here. We started off with a V0. This is just a nice way to test everything out, make sure it works. You break out a lot of pins so you can try different things and maybe add features, and it's easier to solder together and just makes it easy to work with. But then we wanted to make it really small because we wanted it to fit inside of readers and behind readers depending on the installation. So we then went back to the PCB program and shrunk that board down. And at this point, the space constraint is actually just the battery holder. It's the size of the battery holder on the back. In order to go smaller, we would probably need to use a smaller battery at this point. Though, It sounds great and all. We did screw something up really badly, and it's a fun story. So, in development of BLE devices, it's useful to give them different names. The reason being, if Mark and I are in the same room and we're both playing around with these, it's annoying when you have like 10 different devices called BLEKey, and you're like, which one do I click to get to mine? So, you give them just unique identifier, unique names. So Mark, he was working on one, and he had given it a unique name, and he sent me the firmware over, and we sent it off to our manufacturer in China. And then I got this email back.
My 12-year-old self came out during this, let me say.
Yeah, so it says, we have updated the firmware successful, but the BLE name is BLE penis?
All 250 of them.
Yeah, so we almost had like a bag of BLE penises, but thankfully, they were very considering. They reflashed all of them really quick and shipped them out, and we got them all in time, so thank you to Tiny Sign. They're great for getting manufacturing done. And yeah, so what do you do when you have one of these devices? Well, you put it in a reader. So this is the device in this reader. It fits very nicely in a prox reader. There's so much space in there, you can just put it in and close the cover. It works great. And people were asking, we did some calls with reporters and stuff, and they were like, well, how long does it take? It must take a long time to put this in. So we did a speed run, which we'll show you. And here we are. So we pop the cover open, and that's the top cover. Then there's 4 screws to be undone. I swear this is not sped up. It just happened to be exactly a minute. And the 4 screws come off. Great, we're inside. And there's the wires. There's 4 of them. We need 3. So Mark's now lining up that first wire, which is one of the Wiegand data wires, and he's punching that one down. And gets the next one in there.
I had bits falling out of my tools, and I could have shaved 2 seconds or 3 seconds off at least.
All right, one more. And so that's it, all the wires are in. Now we're going to put the reader back together. We'll just do up 2 screws because we're not worried about forensics right now. And toss that top on, and there we go, 1 minute. And sure enough, the door still works normally. And we're just proving here that we can connect to the device still. It's actually in there.
Also, just in case our demos don't work, this is proof that the thing works.
Yeah, if everything goes bad, at least we have this. So Mark's, going to the right characteristic and sending some data. There's no card present, but he hits the button and the door opens, which is great. And we'll show you it for real, hopefully, in this section called the attacks. So let's talk about what you can do with this thing and why you might want to play with one. And in this demo, we're going to do some role playing here, I guess. I'm going to be Alice. We're going to use the cryptography actors. So I'm going to be the innocent person. Mark is going to be the evil Eve. And he's also going to bring stuff up on the screen to show you what's going on as we go through, so you can see how it works. So while he gets that ready, we'll just talk a little bit about this setup. We have, HID prox reader, active strike for the door. So it's an electronic strike plate that is opened by a door controller. And behind it, this is sort of risky, but we'll turn it around. There's a off-the-shelf HID Vertex door controller, like you'd see in any facility using this stuff.
Fun fact, still using the same card data that it had on it when I bought it from eBay.
Yeah, that's never good. So it's as real of a setup as we could get. Nobody wanted to let us break into their building, so we had to build our own building. So what Mark has up right now is a serial terminal. This would not be used in normal deployments. We just have it for illustration purposes, and it's really useful for debugging. So this is a wired connection right now. And when you scan a card on the reader, you should have a line pop up there saying 9 cards have been read.
9 cards, and we have the raw data and then the padded data.
Great, so that's the serial terminal side. And this is the Bluetooth client. So obviously, you're going to want to do this wirelessly. You don't want to have to open up the device and connect to it. So Bluetooth, we can connect to the specific MAC address of this BLEKey. And we have whitelisting enabled on it so that, only certain MAC addresses can connect. But please don't mess with us. So we're connected to it now, and the simplest attack is just going to be reading the card. So Alice walks up, and she scans her card. This thing's going to read it over BLE, which is not the fastest wireless protocol. But there's the last 10 cards. She comes again, she scans her card, goes into the office, and we can do another read cards. The bits are moving. And yeah, now we have another
12.
2 cards because I beeped it twice. And this doesn't look terribly exciting until you realize that that number is all you need to enter into a piece of software like Proxmark in order to write a totally valid copy of the card. So, once you have that information, you can be Alice and walk around the facility just as if you were her. So that's the first really simple attack motivation for the device. But once we did that, we were like, oh, well, what can we do next? And the most obvious one that came up was replaying data. We have access to those Wiegand lines, and we can not only read them, but we can also drive them. So let's say you don't want to have to copy a card, you don't own a Proxmark hardware tool, you don't want to run the software, whatever. Mark can just, over Bluetooth, send this transmit command, and he can send any of the last cards, and sure enough, the door just opened with no card present. You can pause for we'll take it. But you probably don't want to be walking up to clients' doors with your MacBook Pro open and hitting a button. So it turns out that you can also do this from a cell phone.
Please work.
From afar.
Wow, there's a lot of devices in here.
Yeah, this is the risk of testing Bluetooth devices at a in a venue hall is, ooh, will it connect? Will we get interference?
I think we have too many devices.
Yeah, unfortunately, the app for the phone that we're using can't do MAC address filtering, so Mark is currently scrolling through a giant list of all of your Fitbits trying to find our device. But he knows that you took 3,000 steps today, so that's useful. Still no luck?
No luck.
Okay.
Oh, found it.
Oh, you got it.
There we go. So I'm connecting.
Then will it connect?
All right, we're connected. So I pick up the attribute, which is replay. I tell it to write, and FF, which is equal to 255, is the command. I hit send, and the door clicks open.
So we moved on from there to be like, okay, what's next? How much more fun can we have once we have access to Wiegand? And we realized that, hey, it might be nice to be able to do a denial of service attack. Maybe you're running through someone's building and you want to tap a card and then the door opens, you run through, and then nobody else can get into that door for the next 20 minutes or whatever. Sounds like a good feature. So putting this all together is quite useful because you can assign a special control card and we can really do whatever you want with it. So for example, let's say you just have a card with, in this case, you have it, OX dead beef as its hex value.
You see up in the serial that it's going to read the control card.
It's going to read the control card. It's going to replay the last card that was sent, and that's Alice's, card right here. And then after that, it's going to lock out the reader for, we're going to do 20 seconds so that we aren't stuck up here waiting for it, but it's programmable to any length you'd like. So evil Mark, he gets in, closes the door. Now Alice comes back, and she's trying to get in the data center. She just can't get in the data center, though. And now the HSM's being unbolted, and they're in the air vents trying to steal the stuff or whatever, So yeah, those are the 3 sort of demos for if you've installed it in a reader at a site, at a facility. But then after building the thing, we realized this has another totally different purpose. What if we installed it in our own reader that we bought off eBay and then electrical tape back together? This is an HID long-range reader. You'll see it on parking garages everywhere. This is the prox version of it. There is also an I-class version of it. It is just more expensive, and we don't have one right now. The way that works is you plug, 12 volts in the back. The BLEKey is inside of this.
Does anyone have a prox card on them?
So if it is prox, yeah, there we go. So now we have his card data. And if you read his name tag, we'll figure out where it works. So this fits in a backpack. It's wireless. It's totally portable.
Woo.
Yeah, we can have our own cards. So obviously, if you can get in an elevator with somebody, you can probably steal their credential. Also, the speaker can be disabled by pulling a jumper or setting a dip switch. We just have it on for illustration purposes. So you can very stealthily go through and just grab credentials, go back, take that card data like we showed, make fake cards that are totally valid for that building, and do whatever you want. So Mark, where does that leave us?
Right about here. So if you are in the overwhelming majority that has one of these systems, what do you do? First off, probably not the best to blindly trust vendors. Not that they're trying to mislead you, but as we saw from the HID website, the information can be misleading. And the people actually installing the systems oftentimes just don't know. In my experience, when I write a report up, send it over to the client, they bring a vendor in, the vendor in says, well, every system is just as vulnerable. There's no answer to that. So you get a trusted third party in if you're installing one of these systems or if you're looking at auditing your system. Because they all have those claims on their website. 5 years after iClass was broken, the copy is still on the site. So the first kind of real tactical thing that you can do is make sure that tamper detection on your readers is turned on. It's very simple. It's just a switch. And in the newer readers, they also have optical sensors in some of them. Now, this might be challenging because from our experience, oftentimes not enough physical copper wiring is run to the switch to even hook it up because of ignorance during the install process. No one put that in the RFP or RFQ, and so they're trying to get by as cheap as possible. So you have to make sure it's hooked up. You have to make sure you have enough wires, and then you also have to make sure that you're watching the console. So I've been in, let's say, a chemical production facility where the console is actually in the cafeteria, publicly, unlocked, and it's kind of standalone. No one's watching it. So make sure that you're watching it, and that the logs coming out of these systems are monitored by someone. Maybe if you want to get fancy, put it into your sim. Do heuristics on it. If Alice goes in every morning at 8 a.m. and uses doors A, B, and C, but then one day she goes into door D and at 4 a.m., this should probably raise alarm bells. Lastly, you probably want to have video surveillance trained on all of your significant entrances and exits. Because these systems now, as we've seen, are not, you're not able to actually accurately know that Joe or Alice is using the door. You need a camera to verify that person's identity. And I guess that pretty much wraps it up. So I want to say that if you need decent security, you probably want to change your access controls completely. Unfortunately for consumers, there is not a ton of information there on which systems are really secure. We have to trust vendors at this point. And we'd like to encourage them to embrace the security community and allow us to take a look at these systems more instead of erasing that information from the internet. Just want to say thanks to a few parties. Optiv, they produced 200 of these boards. That was pretty awesome. And now 200 are in the wild. So you have a better reason to go to your boss and say, look, this is out there. This is a huge vulnerability. And
you can also get one.
Yeah, and you can get one, and you can demonstrate it.
Where do I get one, Mark?
At the recruiting booth.
Yeah.
And I want to thank my wife for putting up with that messy desk and Todd and whatnot for all of the support. So, Eric?
Yeah, so it's been a fun thing to put together. It's one of these things where we look at some old protocol and build some new hardware that just makes it really easy to deal with. And thanks, of course, to Black Hat for having us, and all of you for coming out and watching our demos that thankfully worked. And thanks again. By the way, all the code and stuff we're going to put up on GitHub. We just have to scrub some specific MAC addresses from it. And we're going to push that all with schematics and everything. We'll tweet out a link, I guess, and if Black Hat puts out stuff,
It's our way of getting you to follow us.
Yeah.
Also, thanks to Jamie Gamble, who was the one that got me interested in RFID, wherever you are out there. Thanks, Jamie.
He's there somewhere. And at this point, we have a few minutes for questions. There's microphones in the aisles, and they've demanded that you go to the microphones and talk so that the video gets the voice. Thanks. And I guess we'll start on the right.
Yeah, so question, why didn't you vampire tap the power connection to get rid of the battery?
So we thought about that. One reason was just an install time, obviously, it's a little faster, it's only 3 wires. Another one was we didn't want to do any melting. It's a 12-volt circuit that's used to power the readers, and down to the 3.3 volts that you're going to need on this board, you're going to need either a switching converter or a really hot LDO, dropout, like a linear dropout regulator. So the problem there being it's either going to get really hot or we're going to be introducing 15 kilohertz switching noise into people's RFID readers. And we don't know what that's going to do, but it might be bad. So this way, we're limiting how much noise we're creating other than being on 2.4 gigahertz, which is above what the prox cards are using. In the middle here.
Yeah, is this limited to just the prox reader, or have you made versions for the other smaller readers?
So
it'll work on all of the I-class that we showed you, and anything that speaks Wiegand. In fact, if it doesn't use the same Wiegand protocol, like bit length, it's quite easy to go in, write some C code to decipher whatever format it's using. So it will work with anything that has a 5-volt Wiegand line, or even clock and data for that matter.
Thank you.
Move to the left.
Yeah, if the system also requires a PIN number, can you defeat that as well?
So you're talking if the reader requires a PIN number.
Yeah.
Yeah, so as you said...
You get it near, it beeps, you enter a PIN number, and you get in.
Right, so there's a few different ways of that being done. So the old prox ones, when you hit a button, it actually just sends that number over Wiegand. So it's just an extra bit on the card, essentially, or an extra couple bits on the card every time you hit a button. So you can record that and then extract the PIN number so that you know it and clone the card. So you show up with the card, tap it, enter the PIN number. I-class, it has this thing called bio-class that's used for 2-factor. It's an interesting concept. They do fingerprint readers and iris scan as well. The problem is that it actually verifies the biometric data against the card. But the I-class encryption is broken. So you can make a card with your own biometric data on it, but somebody else's facility code and card number. So then you scan your fingerprint, and it thinks it's valid, but actually you've faked it. So in most cases, those 2-factor implementations are not great. The PIN is pretty easy to defeat if it's prox, like the one that we showed. Yes, left.
How fast is the Wiegand protocol? Can you brute force the card?
Yeah, that's another potential attack, actually. So that signal that we showed you from the logic analyzer, I believe it's about 40 milliseconds. So each pulse of Wiegand is 2 milliseconds. So we have experimented with changing the timing, and it still works. So that's another attack. It's not in the firmware right now, but we could potentially expose a new BLE service, say, okay, we know the facility code's 200, so just brute force card code 0 to 65,500 and go. And it will be much faster than trying to do it, with a Prox Mark III, because this thing waits for a card to be out of its field before reading the next card. So it would take way less time doing it on the lines.
It really will come down to the card reader, how they've implemented that. If they're going to probably require some delay between cards being read. So you have to tune it depending on what door controller they're using, not reader. Just because it will be expecting, give me Wiegand bits and then wait like 100 milliseconds or whatever it is, then give me more. So depending on that timing, you can brute force at whatever speed.
From we had a code bug last night where we weren't waiting, And actually, it seemed like milliseconds. Like we could probably get it down to milliseconds between cards.
Yeah, it was like we weren't waiting at all a few clock cycles that processor. It was probably about a millisecond or two.
Yeah.
I think just on the left here.
How long does the battery last?
So
Without any power optimization right now, we worked mainly on features, 3 days. One of the cards could be a control card that turned Bluetooth off. It's quite easy. It's just a simple call to a function in C. And that would probably dramatically increase the battery life and also improve your security, because then at that point you're not broadcasting Bluetooth all the time. It would probably bring it up to at least a month easily.
the thing that uses the most power right now is just advertising the Bluetooth data, which isn't necessary 90% of the time when you're not trying to get data out of it. So yeah, by turning that off, we could definitely get it down. But we get a few days out of the batteries right now, which is enough to prove a point, but not ideal, I guess. I think all the mics are free. Are we good? Last chance? They're making us make you go to a microphone. I'm sorry. I'm sorry about it.
We'll repeat it if you want to. Just say it, I'll repeat it. Are we selling them? We're giving them out at the Optiv booth. So there's 200 of them there. If they're all gone, if people weren't here and they want one, if there's interest, tweet at us. And we're looking at doing maybe another 100 run, and we can just sell them for whatever our cost is. We're not looking to make cash, really. And you can, obviously you can make your own as well if you just download the design file on KiPad.
Anything else? It's hard to see from up here.
Thank you, everyone, for your time.
Yeah, thanks again.